Hello and welcome back, guys. So today in this video, what will we be studying? We will be studying mathematical induction, the same as our previous video, but in that video I just introduced you the concept. Now we will be doing three mega questions, not one, not two, but three mega questions. Let's do it. Okay, so first of all, question number 8. Prove by induction that this big thing is equal to this thing, this little thing. Yeah, interesting. Okay, so first of all, we need to see this. There is a dot over here. I don't know what a dot means. A dot is basically multiply. Okay, so let's do it step by step. What did I tell you about the three steps? These are the three hypotheses. It is H1, H2 and H3. First of all, let's do the H1. That's a good color actually. I never tried it. Okay, so for step 1, what will we do? We will let n be equal to 1. Okay, so what will we do? We just assume that n to be equal to any number, and then we could add that up, because we can't just prove for every positive integer right away. First we need to assume a value of n. Like a smaller value is easier because you can just add and just get the answer. Okay, so now all I need to do is plug 1 in this equation. Okay, let's do it. So first of all, the sigma sign. Yeah, a vocabulary backlash over here. Never mind. So the sigma sign would be replaced, because when we have a 1 over here, r equals 1, and a 1 in the above instead of n, that means that we need to take start from 1 and end to 1. That means that this sign over here is meaningless. Okay, so let's just remove this sign. Okay, so what will we do? We just put 1 times 2 power 1 minus 1 over 1 plus 1. That is the left hand side, by the way, except the sigma sign, because sigma sign doesn't matter. 1 plus 2 should be equal to 2 power 1 over 1 plus 2 is 3 minus 1 over 2. Perfect. Now what do we do? This is 2 minus 1 is 0, which means 2 power 0 is 1. 1 times 1 is 1. Okay, simple as that. 1. I like that color actually. I'm just going to do the entire thing with this color. I don't know if you like it or not. You have to like it. 2 2 plus 2 times 2 times 3 6 would be equal to 2 power 1 2 over 3 minus 1 over 2, which means 1 over 6 is equal to, this would multiply over here, which would be 4 minus 3, which would be 1, and the denominator would also be 6. So as LHS equals RHS, so we can say that this is true for n equals to 1. Okay, simple as that. Now let's try it for the second hypothesis. What is our second hypothesis? Our second hypothesis is H2. Wow, great. Our second hypothesis is basically we need to let it be true for n equals to k. That means that it is true from r equals to 1 till n, and n is a number k. Okay, so what will we do is we simply write the entire thing, but with k instead of n. So it would be r equals 1, k, then we have r times 2 power r minus 1. Okay, r times 2 power r minus 1 over, what we have r plus 1, r plus 2. Perfect. Just the question, the left hand side. Now on the right hand side, what do we have? We have is 2 power n over n plus 2. Okay, 2 power n over n plus 2. Yeah, so what would we have? 2 power k over k plus 2 minus 1 over 2. because we don't have an end in this term, so it will come as it is. It's simple, right? Next is hypothesis 3. Okay, and what do we need to prove now? We have made it true for from 1 till k, which is any number. But what if there is some number above k for which it is also true? So we need to check if it is true for 1 till k plus 1. That means 1 till k, then we need to add 1. Okay, so that is the basic framework behind hypothesis 3. This is our main hypothesis. Okay, so let's do it. We already have assumed it to be true till n equals k. Okay, now we need to test if this is true for n equals to k plus 1. Okay, so how do we do that? That is simple as well. R equals to 1 till k plus 1. So the left hand side would be as it is, 2r minus 1 over r plus 1 into r plus 2. Okay, and for the right hand side we will use up till k over here. So what is up till k? 2 power k over k plus 2. This is the exact same thing over here. Okay, by the way, if you still don't understand, just DM me with your question on my Instagram. The Instagram handle is the same as the YouTube handle. It is the mathematician. Okay, so 2 power k over k plus 2 minus 1 over 2 plus, we need to add this term of k plus 1. So how do we add? We add it from here, because this is our basic framework in which things are added, because the sigma sign is over here. Okay, so what will we add? We will add k plus 1 times 2 power k plus 1 minus 1, which means 2 power k, over k plus 1 plus 1, which is k plus 2, and k plus 1 plus 2, which is k plus 3. Okay, that is it. We just now forget about this part, okay, the left hand side, and now just put equals to sign, equals to, equals to, equals to, and in the end the result should be what? The result should be, just zoom in, idiot. The result should be this thing, this innocent small little thing. Okay, and the catch over here is that this is in the form of 2 power n, but we need to prove it, that because n is equal to k, that means that it is in the form of 2 power k, right? That means that it would be 2 power k over k plus 2 minus 1 over 2. But we are proving for 2 power k plus 1. So what should actually be the answer? 2 power k plus 1 over k plus 1 plus 2 is k plus 3 minus 1 over 2. Okay, this should be our resulting equation. And if this comes out, okay, that means that we have achieved our objective. I'll just let it remain over here and move on to the hypothesis 3. Okay, so what is our hypothesis 3? It is, first of all, first step is that we need to find out some common term, something common over here. I can see something, that is this k plus 2 and this k plus 2. Okay, and in the numerator we have a 2 power k as well. Perfect. What else do we need? Okay, so I'll just use the blue pen again. Okay, so 2 power k over k plus 2. So 2 power k would be common and k plus 2 would also be common. Okay, and then we would have just a 1 over here because all the fraction has been snatched away. Okay, then next up, what will we have? We'll just put this thing outside the bracket because this has no similarities. This is the odd one out. This is the, yeah, just bear with it. Okay, so 1 plus, what do we have? The numerator is robbed off from 2 power k. What else does it have? It has k power k plus 1 as well. Okay, 1 plus k plus 1 over the denominator, it does not have k plus 2, but it still has k plus 3. Okay, so it would have k plus 3, and then we would have a minus 1 over 2, the lone warrior as it is. Okay, so now what do? We take LCM. Step 1 is find out something common. Step 2 is take LCM. Okay, I mentioned that in my previous video. If you haven't seen it, you're a naughty boy or girl, and you need to see that again. Okay, just the previous video I uploaded on my channel or page, wherever you're seeing it. Okay, so k plus 3, it is a difficult thing to refer to my YouTube channel and my Instagram page simultaneously, blah blah blah, yeah, but I talk a lot. Anyways, okay, so 2 power k over k plus 2, and then there would be a 2k plus 4 over k plus 3, and there would be a minus 1 over 2, voila. Okay, and then what will we have is a 2 common from here as well. Okay, k plus 2 over k plus 3, yeah. So what do we have? 2 power k, 2 common over here, k plus 2 over k plus 3. Okay, k plus 2 minus 1 over 2. Okay, perfect. 2 power k, 2 into 2 power k into k plus 2. Now just we're multiplying the entire thing. K plus 2 into k minus 3, k plus 3, sorry, and lone warrior minus 1 over 2 as it is. Okay, now let's compare this with our original thing. It is 2 power k plus 1 over k plus 3 minus 1 over 3. Interesting. Minus 1 over 2, sorry, minus 1 over 2. Let's just see if this is right. 2 power k plus 1 over k plus 1 plus 2 is k plus 3 minus 1 over 2. Yeah, that is correct. So that means that we must have made some silly mistake. I must have made some silly mistake. I just do it on purpose for you to identify, that was on purpose. Let's see who can figure out. I will figure out as well, side by side. Yeah. Okay, so 2 power k over k plus 2 comes out common 1. Yeah, then what do we have is 2 power k plus 2 minus 1 over 2. Is that the right thing? Just to be sure, is that actually 2 power k over k plus 2 minus 1 over 2? Yeah, perfect. Over k plus 2 minus 1 over 2 plus k plus 1 into 2 power k minus k plus blah, 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 k plus 2, k plus 3, exactly. Okay, 2 power k plus 2, 1 plus k plus 1 over k plus 3, yeah. 2 power k plus 4 over k plus 3, 2k plus 4 over k plus 3. Yeah, that makes sense. Then 2 comes outside, and it would be 2. Oh. Yes. I did not make a mistake. I can just see that this cuts out. Okay, so now what are we left with? We are left with 2 power k over k plus 3 minus 1 over 2. And what do we have? This thing, we still have a 2, right? Still have a 2 multiplied by k plus 1. 2 multiplied by k plus 1. Yeah, that 2 needs to cancel out somehow. Interesting. So where does that 2 cancel out? Guys, there is some place. Figure it out. I don't know myself, by the way. Yeah. Where is it? 2 power k over k plus 2 minus 1 over 2 plus k plus 1 times 2 power k over k plus 2 k plus 3 2 power k over k plus 2. Yeah. 1 plus this thing, k plus 1 over k plus 3, k plus 3 plus k plus 1, 2k plus 4. Yeah. 2 power k into 2. That is the thing. That is the problem over here. That this 2 needs to cancel out somehow. What if we had a k plus 6 in the denominator? That wouldn't work. That is not possible. K plus 3 and k plus 2 are the denominators. Okay guys, I can't figure out anything. I know you will. I know it's so easy. It's so obvious. You should just know that the answer should come out to be this. And if the answer comes out to be this, all you need to write is shown. That is it. And for the fix of this question, I will upload another video or my Instagram story. You need to follow my Instagram, and then there you will see where the error lies in. Okay, perfect. So let's move on to the next question. Let's do it, guys. We're in this together. This is not very hard, is it? Yes, it is actually. No, it is not. I was just kidding. I was testing you guys. You guys failed. Perfect. Yep. Okay. So question number 9. This is I prove by induction that for every positive integer n, this thing is equal to this thing. Okay. First of all, h1. Test for. What the hell? Why is my e like that? This is like auto making shapes, auto inking, whatever it is that is called. Test for n equals to 1. Perfect. So what do we have? We have is 4 into 1 squared 4 power 1 basically. Then we would have 1 plus 1 2 into 1 plus 2 3 is equal to 1 minus 1 0. That would become 0. 4 power 1 plus 4 power 2 over 3 plus 2 over 3. Okay, what do we get? 4 times 1, 4 over 6 is equal to 2 over 3. That means 2 over 3 equals to 2 over 3. Perfect. So it is true for n equals to 1. Okay guys, so as we are already on 18 minutes into this video, so I won't be taking much time and doing all the thing. I'll just tell you the answer, and then you can do your working on your own without cheating and send me your results. Okay, and if you find any problem, just DM me and I'll reply to you on Instagram, obviously. Okay, so now the thing is test for n equals to k. That will just put us in this position that what we will do is k r equals to 1. What do we have? 4 power. Okay, this is now a bigger and a smaller n thing. Okay, so this should be bigger n. You also need to see that what will cause you confusion. Okay, the bigger n is what you need to put as 1. This is also a conceptual barricade when you don't know what do we need to put to 1. We just put n to 1, and usually if the variable name changes, we just confuse. Okay, so r equals to 1, n, the small n equals to 1. Test for bigger n equals to it. Basically it's not test, we'll assume true for n equals to k. Okay, so now we have k, and then we've had a small n, And then what do we have is 4 power n squared over n plus 1 n plus 2. Okay, 4 power n, back with my blue pen. N equals 1, 4 power n, which means 4 power n, which means 4 power n, basically left hand side remains the same. Okay, so 4 power n times n squared over n plus 1 into n plus 2. Insane shit. Okay, that is would be equal to that would be equal to n minus 1 over n plus n minus 1 over n plus 2, 4 power n plus 1 over 3, n minus 1 n plus 2, n minus 1 n plus 2. Okay, so it means k minus 1 k plus 2 over, what do we have? Oh sorry, that was the denominator, never mind. K plus 2 goes in the denominator, and we would have another fraction. That would be 4 power k plus 1 over 3. 4 power k plus 1 over 3. And we would have plus 2 over 3. Perfect. Now, for H3, what will we have is H3 test for n equals to k plus 1. What will we have as n equals to k plus 1? We will have the same thing, just a k plus 1 over here instead of a k. N equals to 1, k plus 1. Now we would have the same left hand side, 4 power n times n squared over n plus 1 times n plus 2. And on the right hand side is where the thing happens. Okay, so it would be the exact same right hand side from the previous thing, k plus 2, and then we would have a 4 power k plus 1 over 3 plus 2 over 3. We would have a plus, and then we would have a k plus 1 over here, which means 4 power k plus 1 times k plus 1 squared over k plus 1 plus 1, which is k plus 2, and then we would have k plus 1 plus 2, which is k plus 3. So now let me tell you what the end product would be. And the end product would be, if we go over here, it would be simply this thing but k plus 1 plugged into it. So what would it be? It would be k plus 1 minus 1, which would be k. Okay, k over k plus 1 plus 2, which is k plus 3, 4 power k plus 1 plus 1, 4 power k plus 1 plus 1 is k plus 2 over 3 plus 2 over 3. That should be your answer, guys. If you don't get this answer, just DM me and I'll make sure not to respond. I mean, I will respond. Of course, I will. Okay. Next up is the question number 10. Guys, this is your homework. You will do it yourself. I know you can do it. Okay, that this is the hardest question of them all. If you do this, you will get my, I don't know, I don't have anything. Okay, bye bye.